Astronomers have uncovered a sprawling new galaxy cluster hiding in plain sight. A report in the Astrophysical Journal claims the cluster, which sits about 2.4 billion light-years away, is composed of hundreds of individual galaxies, all surrounding an extremely active supermassive black hole quasar. This central quasar, catalogued as PKS 1353-341, is so intensely bright that for decades astronomers observing it in the night sky always assumed that it was alone in its corner of the universe, shining out as a solitary beacon from the centre of a single galaxy. But in reality, this quasar's light's so bright, it's obscured hundreds of galaxies clustered around it, like a bunch of candles being obscured by the glare of a lighthouse beam. The new data shows hundreds of individual galaxies in the cluster with a combined mass well over 690 trillion suns. By comparison, our own galaxy, the Milky Way, has about 400 billion solar masses. The quasar at the centre of this cluster has now been calculated to be some 46 billion times brighter than the Sun. Its extreme luminosity is likely the result of a black hole feeding frenzy. As material swirls around in the quasar's accretion disk, huge chunks of matter from the disk are falling into the black hole, feeding it and causing it to radiate massive amounts of energy as light. One of the study's authors, Assistant Professor Michael McDonald from MIT, the Massachusetts Institute of Technology, says this might just be a short-lived phase that clusters go through, where one of the black holes gets a quick meal, gets very bright, but then fades away again. Or this could be a blip that scientists happen to be seeing. In another million years' time, the same region may look like just a diffuse fuzzball. McDonald and colleagues believe the discovery of this hidden cluster shows that there may be many other similar galaxy clusters hiding behind extremely bright objects that astronomers have miscatalogued as single light sources. The researchers are now looking for more hidden galaxy clusters, which could be important clues to estimating how much matter there is in the universe and how fast the universe is expanding. Back in 2012, McDonald and colleagues discovered the Phoenix cluster, one of the most massive and luminous galaxy clusters in the universe. For McDonald, the mystery is why this cluster, which was so intensely bright and in a region of sky that's easily observable, hadn't been found before. McDonald's put it all down to preconceived notions of what astronomers think galaxy clusters should look like. And because the cluster didn't conform to those ideas, scientists missed it. You see, for the most part, astronomers have always assumed that galaxy clusters look sort of fluffy, giving off a very diffuse signal in the X-ray band. And that's very unlike brighter point-like sources, which are interpreted as being extremely active quasars or black holes. So, the images are either all point sources or they're fluffs. And the fluffs are these giant billion light-year balls of hot gas we call galaxy clusters, while the point sources are black holes that are accreting gas and glowing as matter spirals inwards. McDonald says astronomers just didn't think that a rapidly accreting black hole at the centre of a cluster happened in nature. And that's where the Phoenix discovery comes in, because it proved that galaxy clusters could indeed host immensely active black holes, prompting McDonald to wonder whether other nearby galaxy clusters have also been similarly misidentified. To answer that question, the authors set up the Clusters Hiding in Plain Sight, or CHIP survey, to re-evaluate X-ray images taken in the past. For every point source that had previously been identified, the authors noted its coordinates. Then they studied it directly in greater detail using the Magellan telescope in Chile. If they observed a higher than expected number of galaxies surrounding the point source, a sign that the gas may stem from a cluster of galaxies, then the team looked at the source again, using NASA's Earth-orbiting Chandra X-ray Observatory to identify an extended diffuse source around the main point source. While 90% of these sources turned out not to be clusters, a small number were rule breakers. The brightness of the black hole might be related to how much it's eating. This is thousands of times brighter than a typical black hole at the centre of a cluster, so it's very extreme in its feeding. The authors have no idea how long it's been going on for, or how long it will continue to go on for. But finding more of these things will help astronomers understand if it's an important process or just a weird isolated event. If the CHIP survey can find enough of these, astronomers will be able to pinpoint the specific rate of accretion onto a black hole, where it switches from generating primarily radiation to generating mechanical energy, the two primary forms of energy output from black holes. And that's why this object's so interesting, because it bucks the trend. Either the central supermassive black hole mass is much lower than expected, or the structure of the accretion flow is abnormal.